Before we dig into the math of partial fraction decomposition, let's go over the basic theory right up front, which is that if I have factored denominators and they have exponents, in other words, they're repeated factors like w and w, you have to include both w and w squared in whatever your answer is in its denominators. So let me do that for a few examples. You'll see the pattern. With w minus 1, because there's only one of those, right, it has no exponent, there's only a need to include a single w minus 1 in your answer. When I look over here and I have in green this w plus 2, and that has a squared on it, that means we're including both w plus 2 and w plus 2 squared. And then for the last one, in this example on the left, I have w minus 3 cubed, which means we're going to take w minus 3 squared, and w minus 3 cubed. And we're not going to get into the reasons why this theorem works, but we went over that a little bit in class. That's how we're going to use it for this problem. So let's come over here on the right side, and I want to draw your attention to this factor right here, which in factored form, that's kind of important that we know how to factor this, is going to be x times x minus 6 squared. Okay, great. Now we have a way to write this in its basic design with the a and the b and the c coefficients. That has to come first. And the way that's going to look is you have a divided by x, right? That's my first factor. It was not repeated, so I don't need to include more fractions with that. My next fraction will be b over x minus 6. And my third fraction is c over x minus 6 squared because it contained a squared right here. Okay, so that's now my starting point. Let me clear out the factoring stuff. And I want to write this whole thing again, but with more room made so I can show you some equal denominators. So let's come down here. This is going to take a little bit of work. Negative 2x squared minus 8x plus 108 divided by, look at my denominator, it's x times x minus 6 squared. And that's equal to a over x. And I'm going to write something called a crazy one in an effort to give myself equal denominators everywhere in the problem. See how this fraction now looks like the one on the left in terms of its denominators? Let's do the same to each of these. So my second fraction is b over x minus x, and its crazy one is going to be x times x minus 6. That gives us the denominator we want, which is x times x minus 6 squared. Be careful not to over multiply, because if you give these things more than they need, in other words, if you create exponents in the denominator that are a higher power than you want, it's not necessarily that your math is wrong, it's just that it's going to get very complicated and hard to solve. So once you have everything the way I've written it here, we can just cross all these denominators out using multiplication. Okay, so we just go right across and wipe those out. They're gone now. So I'm going to write this result right here. Negative 2x squared minus 8x plus 108 equals a times x minus 6 squared plus b times x minus 6 plus c times x. And now the trick that you're going to use at this stage is something called the Heaviside method. So first, I'm going to pick x minus 0 because I know that will make very nice things happen right here with my x going to 0. What I get when I plug that in is 108 equals a times negative 6 squared plus b times 0 times negative 6 plus c times 0. You see, some of these just cross right out. That's why this is such a nice number. And what we get is 108 equals 36a, and that gives me a equals 3. So we can put that in a box, save it for later. Next thing I'm going to do is I'm going to set, let's go back to my equation. You see this right here, this number, pointed out in orange. If I pick x equal to 6, that parentheses will go away. So this is a really nice choice I'm going to make. I'm going to say x equals 6. And when we do that and plug it in both on the left and the right sides, I'm going to skip a little bit to make this faster. I'm going to get negative 12 equals a times 6 minus 6 squared plus b times 6 times 6 minus 6. And see, these are going to go away very nicely. And c times 6. So those are gone, and that leaves me with the following: negative 12 equals 6c, which turns into negative 2 equals c. Now that's really great. And you might be lost at this point wondering what to do next, because I've picked all my nice numbers. I can't just pick, 0 again, because I already did that one. So now you just have to pick some random thing. And I'm going to pick x equals 1, because let's be honest, it's easy. You could pick x equals 47 over 5 if you want, but it would be really a nightmare to solve that thing. So plugging this into my original equation with all the x's, my working equation as I call it, is negative 2 times 1 squared minus 8 times 1 plus 108. Okay, see where that's coming from? That's this right here with 1's plugged in for the x's. And that's going to be equal to a times 1 minus 6 squared plus b times 1 minus 6 plus c times 1. Skipping through the math a little bit, and we get to this part right here. 98 equals 25a minus 5b plus c. And now we can use those previous values we found for a and c to make this, well, let's write it out again. 98 equals 25, and what's a? If you remember from earlier, that was 3. And then we say minus 5b, because I still don't know what b is, and I say plus c, and my c is negative 2. And you see b is the only variable left, so we just write that one here. Negative 5 equals b. That's my third variable. And now I'm ready to write the the fraction using its partial sums, right? Or a sum of partial fractions, I should say that way. You get 3, which was my a value, negative 5, which was my b value, and negative 2, which was my c value. Remember to line these up with the correct fractions. This is the the sum of partial fractions representing that original way back here.